Hello, everyone. Good morning. Thank you for giving me opportunity to speak about this global status, prospects, challenges of tilapia production uh, for this program. My outline of the presentation, I'll be around here like giving some background about tilapia, what is going on, and also status of the hatcheries, nurseries, and growth farming in different countries, and maybe also discussing about the challenges and some conclusions or recommendations. You might have seen tilapia is really booming globally, including in Asia as well as Africa. So you can see, they are found in restaurants, supermarkets, big tilapias are there, and there is export market as well. In supermarket, you can see this is in Thailand, well-organized markets on ice, and prices varies depending on the size and the color of the fish, like a red tilapia, relatively higher in price. Also recently, live tilapias are sold in almost every district markets. So you can see these tilapia in shallow water tanks. They are like a steel frame and with the aeration, so they can sell a huge amount of tilapia, live tilapia, in the market, like something like a $2 to $3, depending on the size and depending on the type. And also tilapias are found in supermarkets, which are ready to eat and ready to cook. So whatever types you want is available. So this is so common. It has been so common. Almost what we say, this is like everyone's fish instead of like a poor man's fish in the past. And also these tilapia you can see here, they are also processed or fried sun-dried under the sun, just simple hot air fan. When they produce more than they can sell as a fresh or live. And some people are doing even smoking, making pickles or fermented fish. Similarly, canning and some making powders for the people to make it easier. And if you look at the global production, although tilapias were promoted since 1950s, but at the beginning they were Mozambicus, and they had a problem, and people had a bad impression about the tilapia because of the Oreochromis mozambicus. Now, Nile tilapia, Oreochromis niloticus, came as a gift from Egypt to Japan. Japanese emperor got from Egyptian king. Then Japanese emperor gave to Thai king, and in Thailand, that's how tilapia started in 1965. Then actually king of Thailand has given to the king of Nepal and also Sultan of Indonesia, probably Malaysia. So that's how this night tilapia has been like a royal gift. Whereas on the other hand, gift developed in the Philippines by Iklam in that time. At the moment, it's World Fish, where the office is in Penang, Malaysia. They also developed gift, genetically improved farm tilapias, and they also promoted heavily, aggressively around the world. So as a result, you can see after 1980s, these things were done. Research was done 70s, 80s, and until 90s. Then outcome of those research and then also technology transfer started after that. And then what happened is actually production really increased after 2000. And every 10 years, you can see more than double or even almost triple production has gone that way. So how we see as a food production sector, if you look at only tilapia, now it has actually number one. If you consider individual species, we always say Tilapia is second to carp as a group. But when you look at the individual species, among the group, carps, there are so many carps, Indian carps, Chinese carps, and common carp, all we put together. Whereas in tilapia, an individual species, grass carp was number one. Now you can see Nile tilapia and its hybrid, let's say red tilapia also, if you categorize same, then Nile tilapia has actually overtaken all the individual species, producing like about nearly 7 million ton, actually more than 7 million ton recently. Then, whereas grass carp is about 6 million ton or less. So that's how we should know what is going on. And production system has highly compartmentalized because of the technologies developed, and then many people involved in this sector. Some people do hatchery, some people do nursing, then further nursing, and even another nursing, three. So at different sizes. Some people need bigger ones for the kids, to stock in the cages, and a smaller one for the ponds. So when they do this larger fingerlings stocking in cages, then production cycle becomes shorter and shorter, so that even some farmers claiming like in 3 months, 4 months, they can produce like a 1 kilo size fish, tilapia. Now even there are some people are producing like a 2 kilo size. Now, what is happening in the technology side, like in a broodstock or hatchery side? Hatchery has been really developed really to a larger scale. Mass scale production has been possible. Under that, what they do is a collection of eggs, cleaning, staging, and then incubation and larvae. So these are the systems where developed at the AIT during mid-80s and 90s. Which has been commercialized. You can see large nylon happas. Broods are managed in large nylon happas, and then collect the eggs every week. So then you separate the eggs by stages, so that you know exactly their age group. Then it becomes very effective in terms of maintaining the quality when you do the sex reversal. That's why this has been done really good, and then this technology has gone all over the world. This is one of the examples from the Philippines itself. I don't know how many people you have seen these things happening in the Philippines, but I know I was there. I think 2016 or 17, not sure exactly. And also, when there is a hot summer, sometimes fish die. And there is a solution for a hot summer also, and then there is a solution for winter, cold winter also, like in Bangladesh or India. What they do during winter, they keep their broods in the pond, deeper ponds, so they can survive. And yeah, this is another example in Egypt and some other cold countries. Even they do in like a plastic greenhouses where temperature can be maintained during winter. So the collection is done by easily by using scoop nets. This is the method where our staff, people catch every female and check their mouths, and then see their eggs, which stage, and then they gather them in a bowl if they are same stage eggs from different females.
Okay.
These are the eggs collected in a large commercial scale hatchery. You can see in a single incubator, they are something like a 6 liter or 4 liter size. 6 liter size can accommodate 1 kilo eggs, which is equivalent to 200,000 eggs. So same stage eggs are in the same incubator jar. And this technology has gone all over the world, starting from Fiji, Papua New Guinea, Timor-Leste. I was there last week, and then all the countries in almost all the countries in Asia, including the Philippines, Malaysia, Indonesia, and also even Pakistan, Iran, and then Africa. Many countries in Africa like Zambia, Kenya, all these countries, and then also all the way to Brazil, Colombia, and also Mexico. So this technique has gone all over the world. So some of the examples I'm showing here, this is from Bangladesh, one of the largest hatcheries, produces like 100 million per year, sells 100 million monosex fry. So this is one project by Wolfish where I was helping them to set up hatchery, running very well from government hatchery, then public partnership with the private sector, and private sector hatcheries are there now. They are running profitably. So in larva rearing, we do simple in tray system. In each tray, you can have like a 40,000, up to 40,000 swimmer fry, which are made ready to go for in the HAPA system for sex reversal. So sex reversal is done with the empty hormone. Many people have some questions about empty hormone. Empty hormone was not manufactured for tilapia. It was actually for the human. So we are using the hormone used for human. So there's there should not be no issue. And also the dose we are using is so tiny, like a 60 milligram only per kilo of fish meal or feed. So we are feeding 5 times a day, and then for 21 days. That ensures like a 100% male conversion. All the female convert into males, and male remain male. So this is the after mixing by machine, not by hand. Some people do by hand, but mixing may not be complete. So some feeds may not have equal amount of hormone. That's why that makes maybe some fish which are not getting enough hormone may not get changed. So this is one of the examples in a big commercial hatchery where they produce like a 20 kilo at a time. In most of the cases, they produce like a 5 kilo at a time. So 5 kilo is actually enough for one HAPA, where you can stock up to 30,000 larvae, post larvae, for 21 days, and then they become fry, and then you nurse them for about a week or so, then sell. So this is one of the examples. This person is fitting here. So this technology was used in Bangladesh by a private company. So I have helped a couple of times there, going there. This is one of the most intensively managed sex reversal and nursing system in Bangladesh. You can imagine single hatchery has like a five ponds like this, like a 40 million fry were in the farm at that time. So everybody knows why monosex tilapia grow uniform size. So you have a bigger fish have higher price. For example, in Thailand, bigger fish may have $2 per kilo, Nile tilapia I'm talking. But if you have a small fish like this, females, normally they don't grow, they start breeding. So the price of the small fish is like $0.50, sometimes a little bit more, $1 or $0.50. That's why farmers gain by having higher weight of the males, and then fast-growing males, and then also a higher price for the bigger fish. So that's how they have a double benefit by doing all-male culture. So these are the benefits of what I mentioned just now. Sometimes, if they get enough food, males grow probably 50% bigger, faster, or it can be like something like this. If the male is 500 grams, females maybe 300 grams or something. So there is a big difference, and bigger fish have higher price, especially in Thailand. Maybe some countries may not be that the case. So anyway, this avoids the breeding in the grout pond, so that the stocked fish stocked are having a better chance to grow. So this is the whole picture of this technique here, especially 4 days it takes to hatch eggs, embryo. Then after that, we keep them in the tray system 7 days, and they are ready to swim, start swimming, and then ready to go for sex reversal 21 days. So sex reversal, sex determination happens somewhere here. So we start feeding hormone before that, at least 3 days before, so that to ensure all get the start getting the hormone right from the first feeding stage. That ensures 99% or 100% female, males, conversion of females into male. Then doing nursing around 2 weeks or so. Then grading will be there. Then you sell like a different size, A and size. So this is the one I showed earlier. Now, some of the examples of nursing system, you can see huge number. Imagine if a single Hapa has only 10,000. In some cases, we have 30,000, 20 to 30,000. So huge number and mass scale production is going on because there is a big demand for tilapia farming. And this is also a hatchery which has a really intensively managed indoor system for sex reversal. Grading is so important. What we do, the grading, first grading is done immediately after finishing the hormone treatment, like 21 days. So 22nd day, you do the grading, having different size mesh nets. And then another is before selling, also you do the grading, and then you sell by size. Higher, bigger fish will have higher prices, and then medium, then smaller fish will have lower prices. That's how it's done. This is, for example, here, too small. Actually, there are 7 sizes and 7 level of prices, depending on the size. And the grading systems have been already very well developed. This is like a aluminum bowl, and these holes are made manually. So there is one family doing this in Thailand, and they are selling to sea bass farmers and other species also, not only tilapia. Tilapia actually started using late. Earlier, we used to use this type of, the nets, which are actually very rough. When the fish fry pass through these holes, they get injured. So they become very dull. But this aluminum we found very soft and smooth. When they pass through, there's no scratch. That's why these are used. So always evolving something new. You can see how the fry are conditions at high density with the aeration, so that they empty their stomach, and then they don't make any stool during transportation in the plastic bag, so that they can go like 40 hours away by flight. We used to send from AIT to Brazil, Honduras, El Salvador, something like that. It takes like 50 hours, even days to survive. Maybe 5% mortality can be normal. So packing is done very well in small plastic bags with only 3 liter, 4 liter water. You can put like a 500 if the distance is long, and you can put 1,000 if distance is like a 10 hours, 15 hours only. But for short distance, like 1 hour, 2 hours journey, not necessary to even do the plastic packing. You just transport in like a fiberglass tanks. So this is one example. Another example here, conditioning and selecting, grading before packing. Now, packing, or if you are producing like a very good quality, maintaining good quality, or the market is global. So people are sending from Thailand to America or Europe or anywhere in the world. Even within the country, like in India, they send by plane. The hatcheries nearby the airport, so they're taking advantage. Now you can see some of the large hatcheries producing up to 30 million per month. Imagine uh, they sell like a 1 million monosex fry in a day, which is almost like a $10,000 a day revenue generation is possible. You can see the number of oxygen cylinders, the scale of operation, and this hatchery actually is very well mechanized, and the owner was actually engineer who designed actually the farm in a like a very mechanized way, like there is an automatic lifting of the HAPA system by hydraulics, and also moving fry by using monorail, and then also automatic packing, even plastic bags you can pack at automatic. And then also they try to do some, even counting is a really challenge, so they also show counting machine, so you can do exact counting when you sell, otherwise it can be plus minus 10% or something. And quality monitoring or the effectiveness of that hormone and conversion of females into male is the main characteristics, I mean indicator of the quality in this case. So we have developed also doing the testing gonad squash method, which was actually developed initially by Rafael Guerrero. We apply that same thing, but for the commercial level, like we take 300 samples and keep them for about 1.5 months. The sample comes from during the conditioning time where you sell, like you are selling to a farmer like a 50,000, then you take some sample from different corners like randomly, then keep them for a month or so, then they are ready to do the corner squash. So you can see if they are females, a lot of eggs, different sizes, and then males, dots, sperms are not seen clearly. But in some cases, you may see in between, like a conversion of female is not complete. So in this case, we say this is intersex. So in some cases, you may not identify either male or female. In that case, you say sterile. And then what we do is we count, do monitor these things, doing like every month. So monthly or even regularly, like a weekly, you have different batches so that you can see what is going on in your farm. If there is any problem, like a problem means there are too many females, more than 5% or more than 1% even is a question in Thailand. If you achieve only 95, 96% males, still there are 3-4% females will produce some babies in the grout pond. So people don't accept that. They'll try to find another farm, which is another hatchery, which is producing a higher percentage of male fingerling. So basically there are 4 stages, 3 stages of nursing, and then before growing. So this part is well established so that the grout farmers gain benefit from this, which size they want. Bigger size, then if they buy bigger size, they don't need to wait for long to sell their fish, like otherwise 7 months, 8 months is too long. So this is one example how they are doing, and also this some people are doing even cold winter, say you can have like a white plastic, and if summer is too high temperature, then you can put like a black plastic to get a little bit cooler water. So these type of things can be done also during summer. And then how after let's say hatchery system, nursing system, then you have a grout systems. The range of systems are used from simple pond system, green water system, which is cheap, although less productive, but environmentally this is more sustainable. You have green water, phytoplanktons produce a lot of oxygen, absorbing the carbon dioxide. So, and then cage culture is becoming very popular nowadays. I think because of the tilapia, cage culture has gone, another level of, intensification. Lot of rivers and lot of even canals, people are having tilapia cage culture. You can see some of the examples here. This is in Mekong River in Thailand, northern Thailand, northeast Thailand. This is actually Laos other side, and then sorry, and this is in Vietnam. So how they produce is like a huge number of tilapia, especially red tilapia. You can see here because they have high price. Sorry. So you can see here people are also, farms are using demand feeder. So there are 2 demand feeders in each case. So similarly, Pakistan, India, Bangladesh also a lot of case culture nowadays. In some cases, there are a little bit of problem because it's common water bodies. In some cases, they don't allow because of the fear of pollution. That's why in some cases, the deeper ponds can be used for cage culture, and in cages, you can put like a different size classes to sell different days rather than harvesting all at a time. And more important thing is cage culture is going like a bigger scale with the circular cages where these circular cages were used for salmon industry. You see here, Zambia, Malawi, Mali, Nigeria have visited a number of farms using these cages in lakes, and especially in lakes. And also Indonesia, Malaysia. Now biofloc, you might have heard a lot of news about biofloc, high density culture, and you have microbes in the tank under, so it can be done in a small area, and then with the limited feeding, because you convert nitrogenous waste into microbial protein, which is source of nutrient for the fish. And this is one example from Iran, like our trainee who came here, he started a hatchery and also now using this biofloc technique to expand, because their system, their weather is too hot in summer and too cold. That's why they have to control using plastic. Yeah, this is one example here in Iran. So there are huge things going on. So aquaponics also, the tilapia is very suitable. Everyone knows. I don't need to explain too much about aquaponics system. And recently, USEC and also Owen University, they are promoting this in-pond raceway systems. This is one of the examples in Bangladesh. I have seen in Pakistan, in Thailand, in Vietnam, and China. So they are still, they have proven actually this system is also enhancing the productivity of the ponds. So what they do is they use pump to create a water flow like a like a river inside the concrete tanks, long concrete tanks, where we feed here and fish like the running water, so they can eat more, and then it flushes out the nitrogenous waste from the system, so fish are having all the time cleaner water. So many things are happening. So if you look at all these things, what is going on around the world, it could be very beneficial. Some of the farms might be interested, Filipino farmers. I know Philippines had actually well-developed tilapia culture in the past, even wildlife technology, all these things were happening in there in Tilapia Science Center in CLSU, where I have been there a couple of times, and then we try to train the farmers and then give information. I think that there is something missing, so there needs to be done something more. Otherwise, tilapia production, I think, has gone down in the Philippines due to some maybe weather conditions or climate change. There is one project from FAO, so I was involved a couple of times. I went there under that project to find a way how we can overcome those problems due to climate change and then extreme weather conditions. So overall, what I would say is tilapia is really booming, and this is really having some good impact on the security, food security of the people, especially seafood. And hatcheries are playing very good role in some countries. Nurseries even are organized separately by different farmers buying from hatcheries, and they play middle role connecting between farmers and hatcheries. And this hormonal sex reversal technology is booming all over the world. Although in some countries they had some restrictions, but they have now almost open in most of the countries. So there's no not much issue. It's a matter of understanding. So we need to promote and clarify all these things. And private sector involvement, especially in the hatchery, is really huge. Many poultry farms in Bangladesh, poultry farms in other countries, they are investing in tilapia hatcheries, tilapia farms. The government role is there to promote, to grab this opportunity so that farmers can take those advantages. So then education level training, hands-on training that we organize, and there's a lot of technical assistance program from different countries, and there is so much of opportunity for processing, like a skin is converted to leather, and then also even used for human surgery. Tilapia skin is very suitable, which has been done, I think, in Brazil and some other countries. And more international collaborations is needed. We are happy to do anything. However, there are a lot of challenges, sometimes because of the pollution. Tilapia die. This happened in Thailand. And sometimes this fast-growing industry actually may be unsustainable. So how we can, maintain this sustainability all the way from hatcheries to farming and then consumption, processing. So large sector, private sectors play really good role if you can attract them. Investment need to be attracted, and a high density culture in cases, and then biofloc systems are often failed because some people who try to do from the beginning without learning basics, then they try to run before learning how to walk. So, and then also price competition can be a problem, challenges if more farms are producing, like in Thailand that is happening. Price is going down, which is good for the poor people because they can afford eating tilapia, eating fish. But farmers may lose sometimes, so those challenges are already there. And also the competition among the hatcheries is also going very well. But one way is good that they have to maintain the quality better and better, fast growing, those things. But still the price of the fried fingerling may be a little bit low, and that makes it difficult for the hatcheries to make profit. So adequate emphasis by the government has to be there. In some countries, they don't give enough emphasis on tilapia or overall aquaculture because they don't realize the value of this in terms of trade or economics, and also nutrition, how it works, how it has a better benefit over many other species, and also red meat and other even better than chicken actually. So more training, more education, more promotion is needed. I would be very happy to collaborate with if there is anything. There are a lot of publications that we have done in the past, and even there is a book called Tilapia Manual, business manual. It is a little bit expensive, but it's, I think, worthwhile. So these are the pictures that we had in different time. People coming from Africa, even from Norway or Australia or China. That's how we try to promote tilapia culture and technology. So anybody has any question, you can send me email to this. And also there are information about Aqua Center, which I established in 2014 and offer training and organize other projects. So thank you very much. I'll be happy to answer questions later on. Thank you.